Welcome everyone, and let's talk about the hyperbola. Sadly, I know you're going to be very upset. We aren't going to be in proof fill for the hyperbola, primarily because the hyperbola has a proof very similar to the equation of an ellipse, as I'm going to just kind of skirt around without a proof and let you know. Really, if you think of a hyperbola, we learned about the ellipse, and if you would take this and turn it inside out, okay, I cut it down the middle. This was obviously not very scientific. We have the hyperbola. So we know from our TI Inspire lab that a hyperbola, we take any point that's on the hyperbola, and let's say that these are its focus points, foci. If you take the distance from the point on the hyperbola to one foci, and then I take the distance to the other foci, the difference of their distances is constant. So if I took the distance from P to F2 and subtracted off the distance from P to F1, that equals some constant. Okay, and obviously if I went the opposite way, you wouldn't get a negative value, you would have to take its absolute value. So the idea here is there is a difference. When it was an ellipse, the sum was constant. In a hyperbola, the difference is constant. And hopefully this will make sense when we start talking about the standard forms of a hyperbola. So here we go. What is similar to the ellipse is that you have some type of x squared, your y is also being squared, and it equals to 1. That is what is the same as an ellipse. What's different, however, is you are going to subtract those terms. With an ellipse, you would add their sums because the sums from each of the points on the ellipse to a foci, you would add those distances and the sum is constant. In a hyperbola, the difference is constant. Now, I'll talk about what a squared minus b squared means in a minute. This is a hyperbola that is centered at 0, 0. And I can also have a hyperbola that is also centered at 0, 0 that looks like this, where I have the y squared that comes first, minus the x squared over b squared equals 1. So here's what the difference is. A does not, I repeat, A does not have to be bigger than B. We called it a major axis of the ellipse, and it was the longer length. In a hyperbola, your transverse axis does not have to be bigger than your conjugate axis. So it's all about the variable that comes first. Because the x comes first, this means I have a horizontal transverse axis. So that means my hyperbola is going to be opening up to the left and to the right. When the y squared term comes first, and remember what comes first makes a difference because subtraction is not commutative. Then if the y squared is coming first, then my transverse axis is vertical. So that means my hyperbola is going to open up or down. So this is the major difference between the hyperbola and the ellipse. With an ellipse, you are looking for the bigger number underneath in the denominator to determine where your major axis is. In a hyperbola, the transverse axis is always related to the variable that comes first. Now we know that every hyperbola does not have to be centered at 0, 0. So the general form of a hyperbola where the center is somewhere other than 0, 0, let's say hk, would look like x minus h, the quantity squared over a squared, minus y times the quantity k over squared over b squared equals 1. Again, when my transverse axis is horizontal, so my hyperbola is opening up left to right because my x variable is first. And I can also have a general form y minus k squared over a squared minus x minus h squared over b squared equals 1, where again the center of the hyperbola is at hk, and because the y comes first, then my transverse axis would be vertical and my hyperbola would be opening up or down. Also, we want to note that when we would find information about the foci of an ellipse, on an ellipse we would use c squared equals a squared minus b squared, but when we want to find information about the foci in a hyperbola, we're going to use c squared is equal to a squared plus b squared. C still means, okay, c is going to represent the distance from the center of your hyperbola to a foci. Okay, that is what c squared is going to represent. A and B And remember, A could represent the major transverse axis, or A could also represent the conjugate axis. But the idea is that A squared and B squared are basically going to be the denominators from your standard form. And it doesn't, A could be, but basically what you're doing is you're taking the semi-transverse axis and squaring it, and you're adding to it the semi-conjugate axis and squaring it as well, keeping in mind that this doesn't necessarily mean A and this doesn't necessarily mean A, because it really just depends on which one is coming first. So the idea with the hyperbola is when we want to find information about the foci, we're going to use c squared equals a squared plus b squared. Welcome to example 1. We're going to take an easy example to talk about how we find the center of the foci, and hyperbolas have asymptotes, how we deal with that related to the equation x squared over 36 minus y squared over 4 equals 1. All right, because we don't have any parentheses, we just have x squared and y squared, I have a center that's 0, 0. I also know, because the x comes first, that I have a transverse axis that is horizontal, so my hyperbola is going to be opening up left and right. Now, how do we draw this so that we have a reasonable sketch that is fairly accurate, that has the right bend? This might seem kind of interesting, and if you are wondering where the heck she's getting from, please refer to page 651 in your text. But this is a way that you can visualize how to get the asymptotes, get your equation relatively easily. We're actually going to make a rectangle using the square roots of the denominators. And again, give me a few seconds and hopefully this will all come together. All right. If I take 36, I can think of this as 6 squared. So that means my A is equal to 6. So from my center of 0, 0 at the origin, I'm going to go out 1, 2, 3, 4, 5, 6 units. And I'm going to go to the left. Okay, apparently somebody is walking and my dog is barking. Sorry about that. All right, Harper, be quiet. All right, so I have 1, 2, 3, 4, 5, 6 in this direction. These are going to be the vertices of my hyperbola, because I know that I have a horizontal transverse axis. So my vertices are going to be 6, 0, and negative 6, 0. And these are going to go out left and right, but I need to make sure that I have an accurate graph so I know how wide or how narrow to draw those branches. So now I'm going to talk about the conjugate axis. The conjugate axis isn't really seen in the hyperbola, but my conjugate axis would be from 2 to negative 2. Now, if I imagine a rectangle, and where these meet, okay, this is going to be an asymptote. And then where these meet over here, the corners of that rectangle, there is going to be another asymptote. Okay. With my vertices, this represents my hyperbola. The hyperbola is going to have a vertex at 6, 0, and is going to be drawn along those asymptotes. Okay. So when I want to find the equation of the asymptotes, the common point between both of those lines that are the asymptote is the center, 0, 0. And an asymptote is a line, and so we need to construct an equation of a line. When you determine the equation of a line, you need two things. I need a point, and the point I'm going to use is 0, 0. And the second thing I need is a slope. Well, isn't the slope the change in y over the change in x? Or another way of thinking it, it's your rise over your run. Well, from here, if I rise 2 and run 1, 2, 3, 4, 5, 6, that is the slope between those 2 points, which is 1/3. So a way of thinking about it is, and I don't want you to memorize, oh, half of the transverse axis, half of the conjugate axis, because if it's turned around, you can get confused. Just think of it as, when you draw your box, however many you go up over how many you go over is going to be the slope. So now when I put this together using a point slope, and obviously this is a pretty easy example because it's 0, 0. I'm trying to give you how is this going to work every time. If I use point slope, I get y minus 0 equals 1/3 x minus 0. So y equals 1/3 x is one of my asymptotes. But then my other asymptote is just going to be if I go up 2 and to the left 6. So the slope of the other line is always just going to be the opposite sign of the one I got before. So again, if I use point slope, y minus 0 equals negative 1/3 x minus 0, then this yields y equals negative 1/3 x. And so y equals 1/3 x and y equals negative 1/3 x are the equations of my asymptotes. To find the foci is equal to c squared is equal to a squared plus b squared. My a squared is 36, my b squared is 4. So you basically take a sum of the denominators. That gives me 40. And so when I take the square root of 40, I get 2 square roots of 10. And remember, the square root of 40 is going to be a number between root 36 and between root 49. So it's a number that is between 6 and 7. So if I wanted to plot them, the foci would be approximately right there and there. So my foci is at 2 root 10, 0, and at negative 2 root 10, comma 0. And that is all of the information for example 1. Welcome to example 2. We're going to find the center, the foci, the asymptotes, the vertices, and sketch the graph of the hyperbola y minus 1 quantity squared over 1/4 minus x plus 3 squared over 1/16 equals 1. If this was a test question, I would recognize that this is a hyperbola because the y and the x are both being squared, and I am subtracting, or this is a difference of those two terms. Okay, my center should be pretty easy. Notice that I have, the center is not at 0, 0, but I just take the opposite of 3, which is negative 3, that's my h, and my k is 1. So I have a center at negative 3, 1. There's my center of my hyperbola. Okay. Now, in this case, because the y is first, this means my transverse axis is vertical. And the square root of 1/4 is 1/2. So I'm not going to go very far, but I'm just going to go up 1/2 and down 1/2 in order to get my vertices. So again, this was my center. There's a vertice and there's a vertice. So if I think about it, I was at negative 3, 1. I'm still at negative 3 for each of my vertices, but I had to add 1 to 1/2. So that's 1 1/2. It's 1.5. It's 3/2 for those of you. Any of those representations would work. And then in order to get this vertice, I would have to subtract 1/2 from 1. So that would be 1/2. So my vertices are at negative 3, 1 1/2, and at negative 3, 1/2. And they're going to go up and down, but I have to make sure that I have the appropriate bend to each of those branches. So I need to graph the conjugate axis, which in this case would only be 1/4. So you're only going out just 1/4 on either side of the center. So when I draw my box, it's not going to be a very big box at all. So I'm going to have one set of asymptotes going this way and another set of asymptotes going this way. So remember, my vertices were at negative 3, 1 1/2, negative 3 1/2. I have a vertical transverse axis. So the branches of my hyperbola are going to be going up and down like this. Okay. So let's figure out what the equation is of those asymptotes. Well, again, when I write an equation, I need two things. When I write an equation of a line, I need a point. Well, their common point is the center, negative 3, 1. Then I need a slope. Well, if I think about how I went, my slope is my change in y over my change in x, or it's my rise over my run. From the center to the vertice, I went up 1/2. When I ran, I went from the center to the right only 1/4. And this looks scary, but remember, 1/2 divided by 1/4 is simply 1/2 times 4 over 1, which is 4 over 2. So my slope is 2 for the positive line, and my slope is negative 2 for the negative line. So when I need to find the equation for my asymptotes, I'm going to use y minus 1 equals 2 times x plus 3. So y minus 1 equals 2x plus 6. So y equals 2x plus 7 is one of my asymptotes. It would be this one right here. And then my other line would be y minus 1 equals negative 2 times x plus 3, which yields negative 2x minus 6. So y is equal to negative 2x minus 5. So that represents this asymptote. Okay. Bob might do something kind of weird. He might write it as 0 equals 2x minus y plus 7. And if he does, just know that you can convert however you need to. His standard form is a little bit different than ours for whatever reason. So our equation of our asymptotes then is y equals 2x plus 7 and y equals negative 2x minus 5. Okay. Last thing we want to do is find our foci. So that is c squared is equal to a squared plus b squared. C squared is equal to 1/4 plus 1/16. When I want to get a common denominator, this is 4/16. So 4/16 plus 1/16 is 5/16. When I take a square root, I get root 5 over 4. So what I had to do to get an exact value is my foci is just root 5 over 4. So I had to take 1 plus root 5 over 4 and negative 3, 1 minus root 5 over 4. Those would be the exact values of my foci. All right, so at this time, you are ready to begin page 656, and you can try numbers 1 to 13, the odds, at this time. Good luck.